warm welcome. Regard so action engine. Now screen दे दीजिए. Yeah, my voice is audible at this moment, I hope. Yeah, so and I hope now it from the start. Okay. हेलो 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 हेलो, अभी आ रही है वॉइस? अभी आ रही है? अभी ओके? स्क्रीन दे दीजिए एक बार. या आई होप माई वॉइस इज क्लियर एट दिस टाइम गाइस. या Akshay, Vijay, just help me out. My voice is okay. We can start the session as soon as possible. First make a check, then we can start the session. Yeah. Yes, now, okay, thank you so much. A bit glitch at this moment, so no issues. And for this, we are going to have an algorithm class today, basically. Huh. Or, yeah. Okay, so now we are going to अभी ठीक है फ्लक्चुएशंस हो रहा है क्या फ्लक्चुएशंस हो रही है फाइव मिनट्स वॉइस आएगा वॉइस अभी है just wait for 5 minutes. 5 minutes, we have a technical issue at this time. हाँ ऐसे ना ये हेलो अभी वॉइस आ रही है अभी वॉइस आ रही है स्क्रीन दे दीजिए एक बार अभी वॉइस वॉइस आ रही है ना या ठीक है okay sure yes a big yes right now I hope there should be no technical issues at this time okay now it's everything is sorted out now about फिर से मैं बोलता हूँ okay again we are able to start the topic then first we are going to talk about a generalization in today's class basically we are going to see how we can use aptitude skills okay to use aptitude skills to solve any CRE numerical whether either from any of the topic either it is homogeneous, yeah, heterogeneous, or any of the questions from different exams. Okay, so basic, what are the basic techniques? Even though you are very weak in CRE, so how can we approach to any numerical? So there are some set techniques. Okay, so we have some techniques to follow, and on the basis of techniques we have two simple numericals, and those numericals are not directly from the CRE, and also we have connected another subject which is process calculation. Okay, so in and around we are going to see how to tackle the situation, right? Rather than we think about problems, so we need to think about the given situation and how to respond to it based on our technique. Okay, so first we make sure that what are the basic techniques that we can follow. Okay, so I just write techniques. Either it is techniques or algorithm. Okay, so techniques, or we can just write algorithm or the process. Okay, so techniques for solving a CRE numerical, okay. Okay, so this class here, this session is not restricted to any of the exam. Okay, it's a general thing. Okay, when you face as a chemical aspirant, when you face any exam, when you try to face any CRE numerical, how to approach, that is the first problem. Okay, calculations is easy because you have a calculator, you can solve the questions, you can have the numerical values, that's fine. But the main aptitude lies how to solve the situation, come to the conclusion. Okay, and the first technique what we can see, that the first technique what we can follow, the first technique has to be, can anyone just let me know what is the first technique when you see any CRE question, what it comes to your mind? Okay, what is the first thing that comes into your mind? Okay, the first thing is you need to identify something, because when you see something you just identify, you just give a name to it, right? So first our function has to be identification, right? So first you need to make sure it is identification. Okay, what you need to identify, something has to be identified. Okay, if I ask you one question, so what is the thing that you are exactly going to do? Okay, so what is the first thing that you are going to identify? Any one of you guys, what is the first thing that you are going to identify in a given CRE numerical? Okay, any of the situation, because I am not concerned about only one specific situation. In general, when you solve any question, what is the first thing that you're going to note? Okay, and that will be the first point. Yeah, anyone? The first thing will be you need to identify, the first and foremost thing, you need to identify which phase reaction is. Okay, either it will be liquid, yeah, gas, yeah, it will be combined, the two state. Okay, we can say as heterogeneous. So basically we need to make sure that we need to identify the phase. We need to identify the phase. Okay, the phase of a reaction going on, okay, of a reaction system, या फिर reaction mixture. Okay, what is a phase? That is the first step you need to locate. Many of them do not see that phase part. Okay, they try to see the entire question, but the first step that has to be considered, the first thing is your identification of the phase. Okay, identification of the phase of reaction. Okay, now on the basis of phase we have homogeneous and heterogeneous. Okay, now we need to make sure on the basis of phase we have homogeneous, and the other one will be heterogeneous. Okay, so you know this fact. Okay, now under homogeneous we have two phase again, one is liquid and other one is gas, constant density and variable density system. You have two distinct phases in terms when we talk about homogeneous. Okay, so when we talk about homogeneous, again we are just making sure it is divided into two parts. One is constant density system. Okay, constant density system, and other one will be your variable density system. Variable density system. Now these are the two systems that we usually follow, okay, when we talk about homogeneous. Okay, now instead we just make sure that I just write in these terms, in terms of concentration, as in this way. And when we talk about variable density system, because reaction mixture may expand or contract, or it may remain same, so I just make sure it is Ca equals to Ca naught into 1 minus Xa by 1 plus epsilon AXA. You usually write in this notation. Okay, now I'm not talking about what is the, I would say, what is the expression. Okay, we are not talking about what is the expression here. We just concerned with the technique. Okay, the first technique that we need to make sure that you need to identify the phase of the reaction. Yeah, You need to identify the phase of the reaction. Karan, I hope now the voice is clear. I hope my voice is clear this time. Okay. So first we need to make sure that we need to identify the phase of any reaction for any CRE numerical. Okay. Either it is homogeneous, heterogeneous, any of the stuff. Okay. Now when we talk about the second part, we talk about identification of the reaction rate. You need to talk about identification of reaction rate. Okay. Identification of reaction rate, that is the second part that we need to talk about. Okay. Okay. Now if we know the rate, expression of the rate, we need to convert that expression for the according to given question. Okay. Some data will be given in the question. Accordingly, we need to convert the given rate expression. Okay. That will be the third technique. So I just make sure right here third technique as we need to convert the reaction rate. We need to convert the reaction rate in terms of question. Okay, in terms of question, whatever the question is has been asked, in terms of what it has been asked, so we just make sure we just write question over here. Okay, now this will be a third technique. Okay, the technique means the process sequence that you should follow. The first thing phase, the second thing rate, reaction rate basically. The third thing is you need to convert this reaction rate in terms of given in the question. Okay, whatever the question is, you need to just simplify the rate, reaction rate. Okay, and the number four what we talk about, and just we have some react, because when we talk about any CRE numerical, we talk about a reactor system, because we should have a reactor to get the conversion, right? So the next step will be identify the performance equation. Identify the performance equation. This will be the next step. Okay, so identify the performance equation. So this will be the next step. Performance equation. Identify the performance equation. So this will be number 4, and the number 5 is, as you get the performance equation as well as the reaction rate, you need to combine both of them. Okay, so you need to combine both of them. So the next step will be combine reaction rate and performance equation Okay, now these are the steps which are generalized. I'm not talking about a specific question. When we talk about generalization, so we just come across this sequence. Okay, so combine reaction rate and performance equation of a given reactor, whatever the reactor is. So performance equation of a reactor. Okay, so this will be your 5th point. Okay, and the number 6, can just let me know what is number 6. Yeah, just let me know what is number 6. Yeah, anyone? Vijay, Akshay? Yes. Karan, just let me know what is number 6. The last part. You need to solve. Okay, so you need to solve for what? Quantities. Okay, you need to solve for quantities. The quantities means the question has been asked with some related to flow rate, your conversion, your volume, any one of them. Okay, so any stuff may be asked, so you need to solve for quantities. Okay, before we go for any of the question related to solving part, we need to go through this process of 5 steps. Okay, 1 2 3 4 5. Okay, so first we make sure gas phase, I would say just F phase. Okay, I'm not talking about elaborately related to homogeneous or heterogeneous. I'm just talking about the phase. The second part will be the reaction rate. The third part will be the performance equation. Then you need to combine everything. Okay, when you try to combine, you get an equation which is very simplified form, and from that equation you need to make sure that you are going to solve the question. Okay, now the solving part is not so important when we come to this class, because when we talk about this class, we talk about the sequence of steps. Okay, so let's solve a very simple question, 2 simple questions based on today's class. Okay, based on whatever we have written, just let us see how can we go ahead with the calculation. Okay, so let's start a very simple question. Those who are very weak, else those who are overconfident. Okay, now these two category of people are doing a lot of mistakes when we go for any exam. Okay, either they're underconfident, either they're weak, okay, else they're overconfident. Okay, so the best part is you should be confident about any numerical or about any situation when we solve. Okay, then the first thing is that when we try to see the picture, the overall picture of any CRE numerical, we have these 6 steps. Okay, these six steps has to be done very thoroughly. You try to practice as soon as possible. Okay, when we talk about all the 6 steps, we should make sure that all the 6 steps has to be practiced for every sort of question that we encounter. Okay, so let's begin with the question number 1 for this technique. Okay, let's suppose we start with question number 1 here. The question number 1 on your screen here, just go through it. You have a very simple question. I'm not making very elaborately. Okay, I'm not talking about very tough part, but basically a very simple question on the basis of gas mixture. When we talk about the gas mixture, here it is 50% A and 50% inerts. At 10 atmospheres, it enters a flow rate of 6 liter per second at a temperature of this much Kelvin. Okay, and the calculated volume of Cstr if rate of reaction has an expression in this way, which has 80% of conversion, and we need to assume the some cases which is ideal gas, and also the R value is given as 8.314, which is in SI units. Okay, now when you see such question, any question, because any question is should not be underestimated. Okay, every question has to be challenged. Okay, so accordingly, how can we proceed? Okay, now when we talk about when we talk about something, we need to see the calculation part. Okay, what it has to be identified. Okay, the first thing is volume. Okay, the Cstr volume, any reactor volume has been asked in this question. Okay, so basically when we target any specific quantity, we need to target the first thing is all about the volume according to this question. Okay, so when we talk about the question, just let me know you have this whole question. Let's start. Okay, how to start? So I'm just writing the sequence of steps in the right hand side, okay, and the calculation part in the left hand side. Okay, so that you can also know the steps how to proceed for a given question. Okay, so first thing is that we need to make sure, let's start, we need to make sure what is the phase reaction here. According to this question, it's a gas phase reaction. That means you have identified the phase. Okay, now second thing, you need to identify the reaction rate, but here in this question there is nothing such written in this question. Okay, it is nothing written here. There is no reaction rate about reaction rate. It is minus 1 by Ra equals to 800. Okay, the value has been given, but it has not very specified either it is second order or first order or something like that. Okay, now we need to make sure that if we have such expression, just leave it. Okay, do not worry about the extensive concept of reaction rate. Okay, just locate the facts. Okay, the first fact is according to given algorithm of the given question, just we need to make sure the first thing is that it is a gas phase. Okay, so first has been identified, it is a gas phase. Okay, then second, we just make sure, just put an arrow mark. Okay, and just write the second part. The second part is your reaction rate. The reaction rate has been given as minus 1 by Ra. Okay, so minus 1 by Ra has to be written here, minus 1 by Ra. Okay, minus 1 by Ra has been written. Okay, I'm just writing whatever mentioned in the question. So next part is your performance equation. If we know the performance equation, then only we can solve for the volume. Okay, so volume has to be solved with the help of performance equation. So performance equation has to be used for Cstr. Okay, so we just write here, and the third point is the performance equation of Cstr. The performance equation of Cstr. Okay, performance equation of Cstr. Now you just see there is very little number of steps, as you can see, 1, 2 and 3. Okay, and also we're not talking about whether it is variable density or constant density. Why? Because in minus 1 by Ra, when we talk about minus 1 by Ra, it has already been given to you. Okay, minus 1 by Ra is given to you, so we do not talk about those two expressions, basically constant density and variable density. Okay, so we are not expanding to that much, and we just make sure that we have only 3 steps in order to solve this question. Okay, after we get these 3 things, then only we can able to put the values and get the solution. Okay, yes. So how can we approach? Just let me know how can we approach. The first thing is that just do check. Now the gas mixture is containing, this is gas mixture has been given to you, okay. Now it is containing two parts, one is 50% air, the other one is 50% inert, okay. Now temperature has been given as 422.2 Kelvin, okay. Now these things are given to you. Now first we need to assume that the gas mixture is ideal. Now this will be the first step, okay. The first step will be ideal gas mixture, okay. The first, just write it down, it is ideal gas mixture is given. So if it is ideal gas, we just write PV equals to nRT. We know this fact, right? Right. So if we write in this way, just we need to manipulate, okay. So how can we manipulate? We just write P equals to N by V RT, right? Right. This N by V represents concentration because moles per unit volume is concentration, okay. Now this P will be equals to Ca naught into R into T, okay. So everyone know this, okay. Now what is this pressure? PT, okay. Whether it is PT या फिर आपका A का है pressure, हाँ, let me know. Whether it is for A, whether it is for P, just help me out. Yes. It is your partial pressure. It is your partial pressure. Because we are writing pressure with respect to A. Because we have a gas mixture and A is having an individual pressure which is partial pressure, and this is your partial pressure. So we could not relate this partial pressure with your total pressure, okay. And this total pressure will be written in terms of partial pressure here in terms of mole fraction, which is gas mole fraction, okay. So we just make sure that we just write over here as YA naught into total pressure, okay, because total pressure is given in the question, okay. So we make sure that partial pressure has to be written in terms of total pressure, that equals to what? Ca naught, okay. The value of Ca naught is what? We do not know because we need to find, and this R is given as something as 8.314. We need to make sure that we should not follow the question blindly. No way. We need to make sure that our value has to be written in terms of the units mentioned in the question, okay. The units are somewhat here liters, alright, liters, moles, Kelvin, right. So R has to be in form of 0.082. The value of R in terms of, we just make sure here liters is given in the question, okay. So we just write it is 0.082. Now this value has to be used instead of this, okay. So try to see the basic parts, okay. We should not follow the question blindly, never. They want to make sure that they want to confuse you, so make sure that everything has to be consistent with the data, okay. The data has units, okay. From the units we are able to say that the R is having a value which is 0.082, okay. So we are going to use the value of 0.082 here instead of R, which is equals to 0.082, okay. I'm just writing over here R, then I can put the values here. So this is R, which is R into T, okay. So here first you need to calculate which is Ca naught, which is equals to, we just write Ya naught into Pt by RT into RT, okay. Now help me out with the calculation, please. You know the calculation, right? You put the calculator, you just use the calculator and get the answer, okay. Now why we are using the Ca naught, why we are calculating Ca naught? Because in the last step of the algorithm we know that performance equation of Cstr has to be used, okay, in order to know the volume, okay. In the performance equation of Cstr, if you know the performance equation of Cstr, we know that it is V equals to something, we just write Fa naught into Xa by minus of Ra. We know this fact, right? We know this formula, okay, of a performance equation of Cstr. Now from this performance equation we can know the volume of Cstr, right? So we should have the value of Fa naught, okay. It's not been given here. Fa naught comes from Ca naught, okay. That's why we're calculating here Ca naught, okay. Now Ca naught has to be used here, okay. Then we know the value of V naught, which is volumetric fluid given in the question itself, which is 6 liter per second, okay. And along with that we have conversion which is 80%, okay, and minus 1 by Ra. It's the direct value of minus Ra is given, which is 800. So you can put the values and let me know the answer for Ca naught first. Yeah, Ca naught first, jaldi batao. Ca naught first. Yeah, what is the first value that you get for Ca naught? The Ca naught, Ya naught, I just write 50% because in the gas phase, in the mixture, we have two components. One is your 50% A and other one is 50% I. So gas mole fraction, this is gas mole fraction, it can be written as 0.5. The total pressure that you get here, I guess it is 10 atmosphere. So please remember, if the units are in atmosphere, liters, then only you are having a R which is equals to 0.082. Okay, so we just make sure that just put the values here, 10 atmospheres. Okay, then R is having something as 0.082. Okay, so R is having something as 0.082, and this is multiplied by temperature, and the temperature has to be in Kelvin. It's given in the question, I guess. I think it is 422.2. Okay, so it is very basic question. I just want to make you sure that even though you know the basics of the subject, you do not know how to proceed with the calculation. Okay, so in that way we can make sure it is something as this. Okay, so I just not write the unit over here, so values have been written. So let me know what is the answer for Ca naught. Okay, if you know the answer, just help me out. Yeah, Anuj, great. Just help me out. If you know the value of Ca naught, just help me out. Okay, Ca naught. Then we can go for the volume. That is another part of the calculation. The first part is your calculation of initial concentration. Okay, now how we are approaching to this question? By simplifying this part. Okay, we have started from here. Okay, so any gas mixture, when you come across any homogeneous phase which is a gas phase reaction, when it is given in this way, okay, when any gas phase reaction question comes, just try to make sure that if there is ideal gas equation has to be used. So ideal gas equation will be giving you Ca naught. Okay, that means in the question, if there is a pressure, then you need to definitely find the value of Ca naught, because we know the performance equation of a Cstr in terms of concentration of flow rates. Okay, so if we have been not knowing, because performance equation for any reactor is known in terms of your concentration flow rates, right? We are not writing in terms of pressure over here, right? So hence the pressure has to be converted in terms of concentration for any gas phase questions. So basically this question is a single phase and it is homogeneous reaction. So accordingly we need to make sure what is the value of Ca naught. Yeah, quick, what is the value of Ca naught? Just help me out. Then I can go ahead with the calculations. Okay, now first part has been identified. This is the first thing happened. The second thing is minus 1 by Ra. Performance equation is the third part. Okay, the performance equation is the third part. That means I'm just writing over here, which is V equals to volume of MFR. Basically Fa naught can be written as, this is flow rate. Okay, flow rate can be expressed in terms of V naught into Ca naught. Okay, this is one thing, and it is followed by conversion, which is Xa by minus of Ra. Okay, so I'm just writing over here the value of V naught, which is given as 6 liters per second. Do not change the values until and unless the units have been mentioned in a very different way. So we need to make sure that same thing has to be written. It is 6 liters per second. It is 6 multiplied by the Ca naught value still needs to be calculated. So I'm just writing the whole expression here. It is 0.5 into 10 by 0.082 into 422. Okay, 422.2 into Xa. Xa is directly mentioned, just write it 80%, which is 0.8 by it is minus 1 by Ra, just multiplied by 800 over here. So just make sure it is 1 into 800. Okay, it is minus 1 by Ra. So this will give you the answer, the final answer for the volume of MFR. Okay, this type of question usually comes for 1 mark. Okay, they do not ask for 2 marks generally, so they ask for 1 mark. So anyone just help me out with that calculation, please. What is the answer? I'm just putting a dash over here so that you can know let me know the answer. Okay, now this question is quite very easy because we have been given around 3 to 4 statements. In that statements itself, we need to make sure the R value has to be taken as 0.082. So why? Because the units are in liters and atmospheres. So accordingly we need to make sure that R value has to be written correctly. Okay, we need to make sure everything has to be consistent. So before we start these steps, we need to make sure units are consistent. Okay, so and the 0th step, just we can make sure here, the 0th step is units consistency. Okay, units consistency, plays a very vital role. That's why many of the GATE questions try to prefer to give these type of questions in terms of NAT, okay, numerical based questions, because they try to see whether they are checking the units or not. Okay, in other exams as well they try to check. Yeah, when we come across calculations using NAT type, so we try to see that whether the units are consistent, what they have been asked accordingly. Okay, yeah, the CA0 value is coming at 0.144 exactly. So it is 0.144. Okay, and what is the value of volume? What is the value of volume over here? What is the value of volume? You know the answer. If you know the answer, just help me out. It will be in liters, because everything is in liters, because we know the volumetric flow rate, it is in liter per second. So we just make sure the volume has to be in terms of liters. Okay, yeah, exactly. Let me know the answer. Yeah. Let me know the answer. This is the first question, a very basic question. Yeah. The liters volume should be in liters and the concentration has to be in mole per liter. So make sure I'm also writing the units, so that you can be very sure that about the units. So units has to be reflected in every way, in all terms of volume also. Okay, yeah. CA0 is 0.144 anything. So I'm just waiting for the answer. Okay, so you can just let me know the answer for the volume. At least try to calculate. Okay, I'm talking about what are the steps should be followed. Okay, the steps has to be first ideal gas, then we are coming about concentration. The third part is your performance equation, and you need to put the values in performance equation to get the volume. Okay, and the volume is something as something 533. Okay, something around 533. You can say that 533. I'm approximating. It is around 500. Okay, no issues. Okay, it is around 500. Now this was very basic. Okay, now let's see how can we proceed with another type of question in which involves somehow not exactly reaction engineering, also the other subject also. So let's tackle the situation, not the subject. Okay, we are not talking about the subject about the subject here. We are talking about the situation and how to respond it. Now let's go for the next question. Let's go for the next question over here. This is the next question being mentioned over here. Try to see. Okay, first I will like to ask you whether this question is right or wrong. Okay, then we can proceed with the answer. Okay, whatever the solution is, just help me out whether the question is right or wrong. Okay, just do check. Mention everything carefully. Just do check and help me out whether everything is right. Okay, कुछ ना कुछ यहाँ पे गलती है. अगर गलती है आप बताओ. Else we can proceed with the solution with algorithm. Yeah, let me know. Quick. Yeah, कुछ गलती है. अच्छा, everything is correct. Okay, you are saying everything is correct. Is it possible? No, I don't think so. Is it possible? Is everything correct in the question or something is mistake? Okay, you need to make sure that yeah, question sahi hai, right? If the question is correct, then you can get the answer correctly, right? Anything if you can see, just let me know. I have intentionally written the question wrongly. Okay, there is something wrong in the question. Just identify the wrong pattern, a wrong thing, then we can go ahead with the calculation. Yeah, quick. Yeah, anyone guys? You have an elementary reaction which is reversible. Do not get confused with such type of reactions, because it's reversible. You may be thinking that it may be very complicated, right? So how can we proceed? So we have been given the rate equation as well. It's very good. And volume of MFR, again the Cstr question being given. Performance equation of MFR has to be used somewhere. CA0, CB0 has been given. Initial concentration of both the A and B. And the 75% conversion is based on limiting reactant, and the flow rate of A has been asked. A very typical question. First we need to identify whether it is right or wrong. Yeah, Arshad is saying it is minus RB by 2. Exactly. Now you have identified the exact thing. This is minus RB by 2. Okay, because as per relative rates, we just make sure it is minus RA will be equals to minus RB by 2. Okay, now we have tried to make sure that our concept is clear. Okay, our concept is clear, right? Now proceed with the calculation. Okay, how to proceed with the calculation? Okay, how can we proceed? Now you need to answer what is the flow rate of A. What is the flow rate of A? Okay, fine. The flow rate of A, I am talking about volumetric flow rate of A. Okay, volumetric flow rate of A. So I'm just writing here volumetric flow rate of A. Volumetric flow rate of A. I'm talking about volumetric flow rate. Okay. Now volumetric flow rate is in liters per second, maybe because everything is in liters. Mole per liter है. इसका मतलब we have to write V naught in terms of liter per second. So make sure this unit has to be in liter per second. Okay. Now this is your question. Okay. Now how to sort it out? How to make sure that you get the answer? Yeah. How to get the answer? Ramesh is given CB naught. Let's expose the whole question. Let's see the process, yeah, technique. Okay, how can we proceed? Now first and foremost thing, first I'm keeping this question aside, okay, and I'm trying to see how can I get into the solution. Okay, what is my aptitude? So when I talk about flow rate, this flow rate is somehow concerned with the volume, because V and V naught is somewhat concerned, okay, space time somewhat, okay, and the space time comes in the picture when we talk about performance equation. So performance equation, right, in that performance equation we are going to get V naught, exactly, yes. So relate the things now. Okay, how can we relate? I'm relating over here, just do check. I'm not bothered about the calculation of values. I'm not bothered about the values. I'm just saying how to get the things easy and simplified. So I make sure that this is flow rate, which is V naught. Okay, this is V naught. This V naught comes from performance equation. This V naught comes from performance equation. This V naught comes from performance equation. Okay, and performance equation of Cstr has to be used. Okay, performance equation of Cstr has to be used. In the performance equation, we know that we have to use rate of reaction. Okay, minus of Ra. Okay, now why I'm talking about minus of Ra? Because you need to calculate the flow rate of A, right? So we are trying to specify the stream first, because it's been asked about A, so we have to talk about minus of Ra, and we are not talking about minus Rb over here. So in the performance equation, the rate expression has to be minus of Ra. Okay, so better just write the performance equation first. So it is V by V naught, okay, which is equals to, we just write Ca naught into Xa by minus of Ra. Okay, now this is a typical equation that we are going to use to calculate V naught. So basically this V naught corresponds to flow rate of A. This is for A, okay, because we have used Ca naught Xa over here. So accordingly, now let's proceed. Now first statement, I can say that the first step we need to follow, the step number one is you need to identify the limiting reagent. Okay, identify the limiting reagent. Okay, you need to identify the limiting reagent first. Okay, why? Because it's been given that 75 conversion of the limiting reagent. We do not know the limiting reagent because XA, it is a conversion of A, right? We do not know whether the A and B are limiting. Which of them is limiting? So first we need to select the limiting reagent according to step number one. Okay, the step number one is limiting reagent either A or B. Okay, just select, yeah, because just check the initial concentrations of A and B. Okay, first we need to make sure what is the initial concentration of A and B. Ca naught is 2.8, Cb naught is 1.6. okay, so when we see the equation, for every 1 mole of A we have to use 2 moles of B. So according to given values of Ca naught and Cb naught, it is quite inevitable that Cb naught is your limiting reagent, Cb is your limiting, B is your limiting reagent basically, right? So I just speak about B is the limiting reagent. Okay, so B is the limiting reagent. From here onwards we are trying to see how to calculate. Okay, Now B is the limiting reagent. Now this is very important. B is the limiting reagent. Okay. So we talk about this limiting reagent moles in process calculations basically. So it's not a part of CRE. And CRE we talk about volume of reactor or some variables which are concerned with the subject. Okay. Now this whole calculation will be concerned with your process calculation first. And as B is the limiting reagent, we need to find the first thing, which is moles of B, final moles of, my final concentration of B. Okay. Now the second step will be final concentration of B. Now step number 2. Exactly. Yes. Exactly. Expansion factor, since it's a gas phase, because there is no need of using the expansion factor. There is no need of use to expansion factor. We can just see, because minus RA has been mentioned, because rate of reaction has been mentioned. Okay. So we are not going to use any expansion factor if we calculate CA, CB and CR. Okay. If we know the values of CA, CB and CR, then there is no use of expansion factor, because it itself gives the values of minus of RA, and we are going to use the same minus of RA in the given performance equation. Okay. Yeah, Arshad, is it clear to you? Yeah, fine. So यहाँ पे minus R is given, तो minus RA has been given, already the equation is given. Okay, so hence we are not bothering about expansion factor, because just we need to find the value of CA, CB and CR, that's it. And the minus RA can be used here so that we can get the volumetric flow rate for A. Okay, fine. So how can we proceed the step number 2, guys? What is step number 2? ये क्या हो सकता है? अब हमें ये पता चल गया B is the limiting reagent. Okay, we know that B is the limiting reagent. We need to find for the A, the conversion of A. We need to find this one, Ca naught Xa. Or else you can just make sure it is Ca naught Xa by minus of I V by V naught. Okay, yeah. Step number 2. Quick. Step number 2, guys. What is step number 2 over here? Step number 2. Find the value of B, I would say the concentration of B, CB, because from CB we will go with A, because there is a relation between rates minus R and minus RB is related. It's something as minus RB by 2, right? These two rates are related in this manner, so we are able to get minus of RA. Okay, so from B we are going for the A. So for CB we need to make sure, because the conversion is given for the B, that means B is the limiting reagent, so we make sure the concentration of B has to be found out. Okay, the CB will be equals to what? CB will be equals to CB naught into 1 minus XB, right, in terms of conversion, right? The 75 conversion is given, so we make sure here the XB will be 0.75. We have to find XA, right? For the XA we have to make some calculations with respect to B, right? So CB naught has been given as 1.6, so I just write here 1.6 into 1 minus, what is XB over here? XB is something as 0.75, so make sure it is 0.75. Okay, so overall it is 1.6 into 1 by 4. 0.25 is 1 by 4, so accordingly I get 0.4 over here. Okay, now what is the use to calculate CB? Because from CB we will go with A, right? So CB has been mentioned as 0.4. Here the calculation comes into picture. Okay, performance equation basically, right? So here after CB, what is the next step? Step number 3. Step number 3. What is step number 3? CB तो पता चल गया. Now what is the next step? What is the next step? Before we go for the next step, just make sure minus of RA equals to minus RB by 2. Rate defines how much number of moles reacted, right? How much number of moles are consumed, okay, in a given time. Okay, we talk about that. Okay, so the rate defines how much amount of moles are consumed in a given time. That means we need to make sure that how many number of moles, I would say in terms of concentration, how much concentration of B has been consumed. Okay, so how can we deal with it? So we make sure the amount of B left. The third step will be amount of B left. Okay, amount of B consumed. Amount of B consumed. Okay, so how can we make sure how amount of B consumed? 1.6 minus 0.4. Okay, so 1.6 minus 0.4. Okay, the value has to be 1.2, I guess. Somewhat it is 1.2. Okay, So it is 1.2. Okay. Now why we are concerned about consumption of B? Because the rate defines the consumption per unit time. Okay. The consumption per unit time of B is 1.2. Okay. So minus of RB can be written as 1.2 instead. Okay. Minus RB by 2 is 1.2. So from here we will try to know that how much A is consumed. That is step number 4. Okay. The step number 4 comes to be written as, which is step number 4. We can know that amount of A consumed. Amount of A consumed. Okay. What is amount of A consumed? Just help me out. What is amount of A consumed in the given question? Yeah. Anuj, Arshad. Just help me out. How much amount of A is consumed as per given information? Because we have known that B consumed is 1.2. Okay. 1.6 has been taken. 0.4 moles has been left out. And how much it is consumed? 1.2. So according to this, we can know the value for the A consumption. Okay. The concentration of A. Yeah. The concentration of A will be 1.2 by 2. Because we are following this rate expression, which is minus RE equals to minus RB by 2. Okay. Minus RE equals to minus RB by 2. So in this way, we are making sure that amount of A consumed will be 0.6. Right? 0.6 according to relative weight concept. Okay. The relative weight concept will tell you about something about amount of A consumed from the B. That's why we have done all the 3 steps. Okay. So after we do the 3 steps, we are making sure we are trying to see what amount of A has been consumed. Okay. यहाँ तक सबका clear है in this part? Because why we are concerned about A? Because in the performance equation we have to write the volumetric flow rate of A. The volumetric flow rate of A has to be known. So for that reason we need to make sure that amount of A consumed has to be known. Okay. From this concept of amount of A consumed, okay, now can I say that this amount of A consumed is somewhat, we can make sure that CA naught XA, this is amount of A consumed. Can we just make sure, right? This whole part signifies this is amount of A consumed. This itself says that it is amount of A consumed. This is amount of A consumed. Okay. So we know the answer of amount of A consumed as 0.6. Okay. So we are directly writing the value instead of CA naught XA. We just write 0.6. Okay. Exactly. Fine. Now we have written this value. Done. Now what extra things we need to require? We need to find the value of minus of RA, and the minus of RA can be known with the help of this equation, which is CA, CB and CR has to be put. Okay. These values has to be put to find the value of minus of RA. So after we get minus of RA, volume is given as something as 6 liters is given in the question. Just put all the values and your answer will be there. Okay. And the next step, we can make sure that we have to find minus of RA. Okay. So that will be step number 5. So that will be your step number 5. That will be your step number 5. So here step number 5, just write over here step number 5. Find minus RA. Find minus RA. Okay. For minus RA, we know that CB value is known. Only CB is known, because in the second step, we know the value of CB as 0.4. Okay. We have to know the value of CA and also the CR. Okay. Then only we can find the value of minus of RA. Okay. So how can we go for it? We have two more things to find. For finding minus of RA, we need to know the value of CR and as well as CA. Okay. CA and CR has to be known. Okay. Now in order to find the value of CA, what is the value of CA? Just help me out. The CA will be equals to initially how much we are taking, which is 2.8, and just make sure it is writing 2.8 minus of 2.8 minus what has been consumed. So how much it is consumed? 0.6. So from initial, if you minus consumption, then we get how much amount of A is left behind. Okay. So it is minus 0.6, that will give you something as CA. Okay. The CA will be something. You just let me know the answer if you know it. So value of CA has to be something as 2.8, which is initial value. And if you subtract with the amount of consumption, so we get the value for the CA. Okay. Now whenever you get the value of CA, okay, this much amount of moles, yeah, amount of moles has been consumed per unit liter, okay, per unit volume, this amount of moles are been consumed, okay. So if we see that the rate expression minus of Ra, okay, and minus of Rb by 2, accordingly for 1 mole of A, 1 mole of R, okay, 1 to 1 ratio is there for A and R. That means how much amount of A is being consumed? 0.6. That will be the formation of R. The CR value has to be 0.6 because the initial concentration of R has not been mentioned. So final number of moles will be 0.6 for R, okay. So accordingly the CR will be how much? Which will be the consumption of A. How much amount of consumption is there? 0.6, and for that 0.6 we need the value of 0.6 as CR, okay. Now this is something I just write mole per liter, exactly, this is mole per liter, and also here we just write mole per liter again, okay, and here also we just write mole per liter, okay. Make sure everything has to be written clearly so that we can know the facts how we are proceeding, okay. Number one, starting from B we are coming to A, okay, and from A we are trying to find out the minus of Ra. So minus of Ra can be now expressed in terms of a given value as 1.25. I'm just writing here 1.25 into Ca. What is the value of Ca? It is something 8 minus 6 is 2.2, okay. So it is 2.2, I guess, 2.2, okay. And the value of Cb, which has already been calculated in this step, which is 0.4, and just write here 0.4 over here, okay, and the 0.4 square, okay, so this is square minus, it is here 1.5 Cr, okay. So I make sure that we just write 1.5 Cr. Cr is amount of R which is formed during the reaction, which is 0.6, okay, and I just write here it is 0.6, okay. Now let me know the value of minus of Ra, please. Minus of Ra, please. Yeah, it is 2.2. I'm talking about minus of Ra. Ca is known to us, Cr is known to us, and also Cb is known to us, okay. The Cb value is 0.4. These three things are important, so I'm just making sure this is Cb, and this is Ca, and this is Cr. Now we are going to use all the Ca, Cb and Cr to find minus of Ra, and this minus of Ra is going to help you to find the value of V0, which is volumetric flow rate of A, okay. So according to this, let me know the value of minus of Ra over here, please. Minus of Ra, which is rate of reaction. Yeah, quick. Something you get some value, right? Let me know the exact value, please, okay. You take your time and help me out with the exact answer for minus of Ra. Yeah, minus of Ra, minus of Ra, okay. Arshad, I hope you understand why we are not calculating about epsilon A expansion factor. We are not talking about expansion factor because we know the rate expression, right, in terms of all the concentrations A, B and R. So hence we put the values of minus of for minus of Ra, we just put those values, and minus of Ra can be known to us. Yeah, it's something just what you get. Quick, minus of Ra, please. Then we can I just write the expression and with the values, okay. So in this way V has to be taken as 6. It's there in the question, guys. The V is taken as 6. Quite easy. Now let's go into the question and see the value of volume, which is 6, okay. So here the 6 by V0 will be equals to Ca0 XA we have done right now, which is 0.6, okay. Amount of A which is consumed is 0.6, so I just write over 0.6 over here, okay. And the value of minus of Ra, so I'm just writing the whole expression again. So 1.25, 2.2 into 0.4 whole square minus 1.5 into 0.6. So this will be the entire expression which you are going to use and to know the volumetric flow rate of A. So this should be the answer actually, okay. This should be the answer. Exactly. Now, you know what is the basic thing that we are talking about is, I'm not bothering about any calculations at this time because little bit, okay. I may ask you to calculate, that's fine. But when I talk about the specific steps, okay, a given question is all about, you can see that there are something we have calculated regard to moles and concentration, okay. We are talking about limiting reagents, right? So some part was of process calculation and the final part was of reaction engineering, basically to calculate the volume. Okay, so accordingly we need to make sure that stepwise calculations has to be used, and it's very important. Okay, for any questions we have generalized the techniques. Okay, either it is phase reaction rate, or else we can talk about performance equation. There are three things that we usually talk about. Okay, so accordingly we have calculated. Just let me know the answer if you are done with this. It's something minus 0.46. I'm not sure about the answer. Okay, something. Okay, if you tell me the answer, I guess if you let me know the answer, I've just written over here. It should not be minus over here. It should not be minus or something. Just do check. Yeah, V naught A. Volumetric flow rate will be in liters per second. So also I have written the units. Okay. So how many steps? 1, 2, 3, 4, 5. 5 steps. In order to solve this question, we have done with the 5 steps. Okay. Done with this. In tomorrow's class, what we're going to do, we are going to see a question which is based on I would say a non-isothermal system, because we can expand the concept of performance equation there itself, because for any homogeneous reactions we can talk about multiple reaction systems right there itself. Okay, a brief example. Okay, I'm not talking about a chapter wise discussion. Okay, I'm talking about how to assemble everything and how to extract information and solve the numerical. Okay, so this is what we are talking. Okay, 4.6 actually, 4.6. Okay, V naught is 4.6. Okay, V naught is coming as 4.6 according to your calculation. Right. So this is something what we have done so far for this question. Okay, now remember the steps. Even though when you look for limiting reagent, you try to see the values for the streams which is A and B. Okay, and you need to ask, you have been asked the flow rate of A, so accordingly we have used the performance equation for A, right? For A we have to find the conversion for A. So for A, right? So we are talking about only A, so but the information is being given for the B, which is limiting reagent. So accordingly we have manipulated and we have known what is amount of A consumed. Okay, so this is all about the sessions. Today's session was very I would say a very generic introduction, how to process, okay, how to go ahead with the calculation. You have the 4th year people, you are having BARC exam, right? So try to solve questions accordingly, according to technique. There is a generic technique. Okay, so for every subject you have some techniques to solve. Okay, for this subject, especially when we talk about CRE, we talk about volume conversion, right? At the end we come up with those values. Okay, initially we have to make sure that we have been given volumetric flow rate, concentration, molar flow rate, okay, minus of RA. These things has to be known, then only we can go ahead with some more calculations as conversion. Okay, so this is what we have talked about, the whole 2 questions on regard to techniques. Okay, so in the next class, I think tomorrow itself, we are going to have only 1 question. Okay, but we are going to have a beautiful expansion of that question in many number of steps. Okay, so you are going to calculate as well and let me know the answer. Okay, and thank you so much for your time, and we will meet again at the same time at 9 p.m. and the same session for the algorithm of CRE numericals. Thank you so much.